Today we're going to learn how to factor out common terms from a polynomial. And basically, over the next couple weeks, we're going to learn a lot of different types of factoring. So this is the first one. And as I mentioned, it's called factoring out common terms. Now what it actually is the distributive property, which is something we just talked about last week, but work backwards. So what I want to do is I want to start off by practicing something we just did last week, a distributive property question, and then we can talk about how you might work it backwards. So let's start off with a very simple example. This isn't factoring yet. This is just multiplying. So what we're going to do, we are going to use the distributive property, and we're going to multiply the 3x squared times the 2x, and then we're going to multiply the 3x squared times the negative 5. So for my final answer, I would do, for the first piece here, I'm going to do 3 times 2 is 6. X squared times x to the first would be x to the third power. And then for the second term, for the constant part, I have 3 times negative 5. That would be negative 15. And the x squared will just leave there. All right, nice easy question, just like what we did last week. And basically the idea is what we're going to do starting today is we are going to start with this, and we're going to try and turn it back in to this. So let's talk about how we're going to do that. So here's the question we're asking ourselves right now. If I reverse that question, if I gave you a problem where I said, here is the polynomial 6x cubed minus 15x squared, and asked you to factor it, how would we work it backwards and end up with 3x squared times 2x minus 5? Well, it has to do with recognizing common terms. Now, we know what term means. We've been talking about terms. Common means shared or the same. So what you're looking for is a number that you can divide out of every term in the polynomial, or a variable that you can divide out of every term in the polynomial, or a term, a combination of the two. So you want to check every single term, and let's say, for example, you notice that all of the numbers can be divided by 2. That's a common term. You can divide out 2. And let's say you notice that every single one of them has an x in it. You have an x to the 5th and an x squared and an x. You go, well, I have an x everywhere. That's a common term. I can factor that out. So what you're going to do is you're going to divide every term in the polynomial by that common term. So remember, we're doing distributive property backwards. When you multiply, you're putting that number out in front of the parentheses into the parentheses. If you're working it backwards, you are dividing to take that number back out. Then once you divide it out, you write that common term out front, and then you leave what's left over inside the parentheses. So here's an example. It went out of order, but that's okay. This was number 2. So I look at this problem and I say I have 4m to the 5th power plus 2m squared minus 5m. Now the common term is m because if I look at my 3 terms here, I have an m here, I have an m here, and I have an m here. That's a common term. That's the same thing in all 3 terms. Now there is no number to this because there's no number I can divide all 3 of those things by. I can't divide other than 1. We don't bother with a 1. But there's no number that I can divide 4 and 2 and 5 all by. So my common term is m. All right, so what we're going to do now, I said, so our original problem, 4m to the 5th plus 2m squared minus 5m equals, well, this is what we're going to do. Remember, when you're doing distributive property, you're multiplying. When you're factoring, you're dividing. So I want to divide each of these by m. And when you divide it, it doesn't just disappear. It comes out in front of the parentheses. Now what's left over is what's left over after I divide by m. Now when you divide by m, you're basically subtracting exponents. You're saying, okay, I have 4m to the 5th. That means I have m 5 times. Well, if I divide one of them off, I'm canceling one of those and I have 4 left. So what I'm going to have is 4m to the 4th power plus, and then we'll do the same thing. I have 2, now I have m squared, which means I have 2 m's. I divide one of them, one cancels, I have 1 left. So basically I have just 2m to the 1st power, or 2m. And the last one's the easiest one because these m's just cancel. And you just get minus 5. And that's our answer. You know, if I work this backwards and did a distributive property, if you distribute the m to all 3 parts, you end up with your original problem. And that's what factoring common terms is. It's doing a distributive property problem backwards. So even though the questions went out of order, let's go backwards and do number 1 now. So for this question, if I'm looking for a common term, this time it's not x, because see, I have an x here in my first term, but no x in my second term. The common term for this one is actually 3. It's a number, because 12 divided by 3 is 4, and 9 divided by 3 is 3. So this time the common term is a number, it's 3. So let's factor. Now remember, once you realize the common term, you divide everything by that number. I'm going to divide by 3. And then when you divide it, that thing you divided by comes out front. We're doing distributive property backwards. Instead of putting a number into the parentheses, we are taking a number out of the parentheses by dividing. So our first term, 12 divided by 3 is 4. X just stays there because we didn't divide x. Plus, and then for our second term, 9 divided by 3 is 3. And those are our final answers. Those are our factored form answers. We found a common term in, even though I went out of order, in question number 1, the common term was 3, so I divided that out and brought it out front. In question number 2, the common term was m. I divided that out and brought it out front. Now I have one more example for you guys. And this is a good example because this one has actually 2 different common terms. This one has a number part and a variable part. So if I'm looking for my common term, let's look at the numbers first. So I see a 10 and a 5. Those can both be divided by 5. But I don't stop there because I also see x's. So right here I have an x to the 5th, and right here I have an x squared. So I'm thinking to myself, I have 5 x's over here, and I have 2 x's over here. I can take 2 out of both of those. So my common term is going to be 5x squared. And a good shortcut rule for you guys, if you're factoring out common terms and you have powers with your variable, powers of x, you can always take out the lowest power. So because I had 5 x's here and 2 x's here, I'm going to take 2 out of both of those things. So my common term, and I already wrote it off to the side here, but it ends up being 5x squared. So let's finish out this question. Same as before, once you realize the common term, you're going to divide each term by that. When you divide it out, it comes out front, 5x squared. And I'll put parentheses now, and we'll see what's left over after we divide. So for my first term, 10 divided by 5 is 2. And x to the 5th divided by x squared. There's 2 ways to think about this. Kind of our shortcut rule, when you're dividing x's, you subtract the exponents. So you would say 5 minus 2 is 3. So I have x cubed. Now, the reason that happens is because if you have 5 x's on top, x to the 5th means x times x times x times x times x, and you're dividing x squared, which means x times x, you can see this x cancels with this one, this x cancels with this one, and you have x times x left, which is x cubed. So that's kind of the reason behind the rule. The shortcut rule is if you're dividing x's, just subtract the exponents. But that's the reason why. You're actually canceling out 2 x's from the 5 you had on top, and there are 3 left over. Okay, now, then I have a minus, and actually it's going to end up just being a 1. Everything cancels. See, I have 5 divided by 5, which is 1, And the x squared divided by x squared also cancels, and when everything cancels, it leaves a 1. So your final answer here is 5x squared times 2x cubed minus 1. And remember, if you ever wonder if you got the answer right, just ask yourself, what would happen if I did the distributive property? If I took this 5x squared and distributed it, would I end up with my original problem here? And the answer is yes, you would, because we've done the question right, and that's what we're doing. We're doing distributive property backwards.